Hello, today we're going to go through power, current, potential difference and resistance. Before we begin though, what do we mean by power? And also, give an example of something that is powerful. Have a think and when ready, press play to continue. So with the word power, we've previously seen that power is how quickly work gets done. Or we could say power is energy transferred every second. For today though, and electrical power, we have a new equation where power equals current multiplied by potential difference. And if you wanted to learn the shorthand symbols, power is P, current is I, and potential difference is V. And as ever, the units are really important. Power is measured in watts, capital W, current in amperes or amps, capital A, and potential difference in volts, capital V. However, for potential difference, we've seen it before with Ohm's law. Potential difference equals current times resistance. So now, notice I've changed the letters in purple. So rather than writing potential difference, we can swap that in for current times resistance. So power now equals current multiplied by current again times the resistance. We can then simplify that further, and rather than writing current times current, we can change that to current squared times resistance. So power is now I squared times R, where power still is measured in watts, current in amperes, but this time we're using resistance, which is measured in ohms. So from this video, we've now got two equations. The first one, power equals current times potential difference, P equals IV. And the second one, by using Ohm's law in terms of potential difference, we've now got power equals current squared times resistance, or P equals I squared R. But as a reminder, we've now got a lot of equations in this topic. The other one that we've seen before is charge is current times time. And then there's energy transferred, or energy equals charge times potential difference. And the final one mentioned in the video earlier, potential difference equals current multiplied by resistance, V equals IR. So now let's look at an example of using one of those equations. So it says, calculate the current flowing in a television if it has a resistance of 0.92 kiloohms and its power rating is 58 watts. So as ever, we use our strategy. We need to box and underline the key information. So I've boxed current, we've got the resistance, and we've got the power. Next, we need to simplify and write out the values. So current equals I, or question mark, that's what we're trying to find. Resistance equals 0.92 kiloohms, and power 58 W, or watts. Before we go any further, let's check for any conversions. So mentioned before, things like turning minutes into seconds. In this time, we've got a K ohms or a kiloohms. So with kilo, we multiply by 1,000. So 0.92 times 1,000 gives us our 920 ohms. Now this is why it's so important to know which equations we've got and to learn them. So because we've got current, resistance and power, we need the equation that has those three in it. So in this case, the equation to use, power equals current squared times resistance. As ever, we write the numbers underneath the words. So under power, I've written 58. Under current squared, I've changed my I to I squared because it needs to be current squared. And under resistance, I've used my converted number of 920. Then we need to check to rearrange. So we want a value for I squared equals, so that's 58 divided by that 920. And then we need to calculate the answer. However, we've still got it in terms of current squared, or I squared, which equals 0.06. We need to get I by itself. So to remove the squared term, we need to square root. So the square root of 0.06 gives us a value of 0.24 for the current. And as ever, we need a unit. So it's current, and that's measured in amperes or amps, capital A. Thank you for listening. And if you've enjoyed the video, don't forget to press the subscribe button.